The F-47, developed by Boeing under the United States Air Force's Next Generation Air Dominance (NGAD) program, is a sixth-generation fighter jet designed to guarantee air superiority for the U.S. into the 2030s and beyond. As the successor to the F-22 Raptor, it represents a full generational leap in both design philosophy and combat capability. Unlike previous upgrades in fighter aircraft, the F-47 is not merely an evolution, it is a fundamental rethinking of what air dominance looks like in a contested, technologically advanced battlespace. The aircraft has been in secret development for several years, with early flight demonstrators reportedly flying since at least 2020. Boeing was officially awarded the development contract in March 2025, beating Lockheed Martin in a highly competitive selection process. The F-47 has since been confirmed as the primary manned aircraft within the NGAD architecture. It is intended to operate as a networked combat system in conjunction with a family of systems, including uncrewed platforms, space-based assets, and advanced data-sharing infrastructure. One of the defining features of the F-47 is its superior speed and range. The aircraft is capable of speeds exceeding Mach 2 and includes supercruise capabilities, meaning it can fly at supersonic speeds for extended periods without engaging afterburners. This provides a significant tactical advantage by enabling rapid response without compromising stealth. Its combat radius is expected to exceed 1,000 nautical miles, far greater than any current Western fighter, which means it can strike deeper into hostile territory without relying heavily on aerial refueling. Stealth is another cornerstone of the F-47's design. It incorporates next-generation radar-absorbent materials, edge alignment, and exhaust signature suppression. But it goes further than previous stealth aircraft by integrating full-spectrum stealth, not just radar, but also thermal, acoustic, and electromagnetic signature reduction. This means it is significantly more difficult to detect across multiple sensor types, including modern multi-band radar systems, infrared search and track systems, and passive electronic detection platforms. Its engines, likely derived from the GE XA-100 or Pratt & Whitney XA-103, adaptive cycle programs, allow the aircraft to switch between fuel-efficient cruise and high-performance thrust modes. These powerplants also produce the electrical energy necessary to operate energy-intensive onboard systems, including advanced radar, defensive jamming arrays, and possibly even directed energy weapons in later variants. What sets the F-47 apart is how deeply integrated it is within the broader combat environment. It functions as a command and control hub for a new generation of uncrewed autonomous aircraft, known as Collaborative Combat Aircraft (CCAs). These drone wingmen are designed to perform specialized roles such as electronic warfare, surveillance, missile defense, decoy operations, and even direct attack. The U.S. Air Force plans to field more than 1,000 of these drones, with each F-47 controlling 2 or more at a time depending on mission requirements. This increases lethality, survivability, and adaptability without risking pilot lives. The F-47's cockpit and pilot systems are AI-enhanced, fusing sensor data in real time to give the pilot a clear, prioritized view of the battlespace. Machine learning tools assist in threat identification, targeting, and engagement recommendations. This reduces cognitive load and shortens decision-making cycles, critical in high-speed, multi-domain warfare. Pilots will be able to see beyond line of sight via data links with satellites, surface sensors, and other aircraft, turning the F-47 into a flying battlefield. Brain. Armament details remain classified, but it is known that the aircraft will be equipped with next-generation long-range air-to-air missiles capable of engaging targets beyond visual range with greater speed and agility than existing platforms. It will also likely support modular weapons bays that can carry hypersonic missiles, precision-guided bombs, electronic warfare pods, or other specialized payloads depending on the mission. From a strategic standpoint, the F-47 is part of the United States' pivot toward high-end conflict preparedness. Its design is focused on outpacing the rapidly modernizing air forces of peer adversaries through qualitative superiority rather than quantity. It is not expected to be exported, at least not in its early variants, to preserve its technological edge and prevent sensitive systems from being compromised or reverse-engineered. The development costs for the F-47 and its accompanying systems are substantial. The Air Force's NGAD program is projected to cost in the hundreds of billions over its life cycle, with each individual F-47 estimated to cost between $300 million and $600 million depending on configuration and technology packages. However, defense leaders argue that the cost is justified by the need to maintain global air dominance and deter high-end conflicts. As of mid-2025, the aircraft is in the engineering and manufacturing development phase, with full operational capability expected by the late 2020s. Initial low-rate production is likely to begin before 2027, with deliveries to frontline units starting shortly thereafter. Training, simulation, and mission systems integration are all underway in parallel with hardware development to ensure a smooth deployment cycle. The F-47 represents a comprehensive step into the future of air combat. With unmatched speed, stealth, range, and networking capabilities, it is designed not just to survive in contested environments, but to dominate them. Through intelligent systems integration, manned-unmanned teaming, and unmatched technological sophistication, the F-47 gives the United States a decisive edge in maintaining global air superiority well into the mid-21st century.